Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In last lecture, we have discussed about different cases of rotation, and we were discussing the balanced trees. We started with the AVL trees, which is one type of balanced trees. So you may remember that there were four cases of rotation. First was two cases was of single rotation, and two cases were of double rotation. So we may recall that if there is insertion in the tree that causes imbalancing of the balance factor of any node, that node is named, or we mark that node as the alpha node. And if the balance factor of that alpha node is 2r minus 2, then we perform the rotation. But before performing the rotation, we check which case of rotation will be applied to. If the insertion or the inserted element is on the right subtree and on the right side of the right subtree, then we will be performing a single left rotation. And if the insertion is on the left side of the left subtree of alpha node, then we apply the single right rotation. But if the insertion is like this one, for example, this is the alpha node, this is another node, and this node is entered or inserted, and this causes the balance factor of this node as 2 or minus 2, so we will call this as the alpha node. And this is the case where we need to perform the double rotation. For example, in this case we can see the tree is hanging in two directions, for example this one and this one, and the inserted node, this one, is on the right side of the left subtree of the alpha node. So in this case we need to perform the single left rotation first, like this one. So once we performed this one, this tree will look like this, this one and this one. For example, if we say it, let's say x, and this is, for example, y. So once performed this one, so y will be here and x will be here. So this now we can see there is again, if we check, the balance factor of this node is still not under the limit. The limit is you remember, it should be either 0, 1 or minus 1, but in this case it will be either minus 2 or 2. So it means we need to perform another rotation, which will be the right rotation, like this one. So once we do this, the resultant tree will be like this. Y is at the root side, and this alpha node, it will be here, like this one. On this one, the x node, it should be here. So once we do this, we will see that this tree is now in the balanced form. So this was the case of double rotation. And the second case where we need to perform the double rotation is when the insertion is like this one, on the right subtree of the left child of right subtree. So in this case, this will be the alpha. This is the node which is just inserted. So now we can see this is again kind of imbalance in this particular tree. So again we need to perform the two rotations. First rotation will be performed at this point. So for example, if we say this one as A, and this one as B. So the first rotation will be, this should be the alpha node, alpha. So if we move B to A, so B is here like this one, and A is this one. Okay, if you again see, this is now already in the form where we need to perform one more rotation, which is the single left rotation. So this one, like this one. So we do this, the tree will be like this, B, और इसके जो लेफ्ट पे होगा this should be the alpha node, and इसके जो राइट पे होगा it will be the node A. So this will now complete the double rotation case of this particular example. So keeping in mind these four cases, we need to construct a tree. So there was a question in last lecture from some of the students that what if in a given tree more than one nodes will have balance factor of 2 or minus 2. So frankly speaking, it will not be possible, because if we keep on balancing at every point, our algorithm, our code will check after the insertion of every node whether the balance factor is in balanced form or imbalanced form, and if we correctly identify and rebalance the tree, then there will be no given tree in which more than one node will have the balance factor of 2 or minus 2. As soon as we identify that there is a node which is having a balance factor of 2 or minus 2, we will immediately perform the desired rotation whatsoever is out of these four cases, and we will get the tree balanced. So there will be no case if you found some of the cases during the construction of the tree, it will be meaning that you have missed some rotations at some particular points. Okay, so let's start with the example of AVL tree building. So remember, this AVL tree is a kind of BST, binary search tree. So it should be constructed according to the principles of binary search tree, but whenever there is a change of balance vector, we will perform the rotation in order to make it the AVL tree. So let's start with some given data. For example, we say insert 1 in a given tree. So this will be because we have the empty tree, so this will become the first node of the tree. So we can check the node is having balance factor of what? Balance factor is, formula was height of left subtree minus height of right subtree. So in case of empty, we remember the height of empty or blank subtree will be minus 1 minus height of right subtree. So right subtree is also minus 1. So it is equal to now 1 minus 1 plus 1 plus minus 1 plus 1. So 0. So it means this is already in the balanced form. Okay, insert 2. So insert 2, we will compare the value 2 with the root node. So it means root 2 is greater than the root node, so it means it will be added to the right side of this node 1, like this one. Okay, so once we inserted this, we can see the balance factor of this one should be 0, because height of left subtree, which is minus 1, height of right subtree, which is also minus 1. So minus 1 minus into minus 1, which is plus 1. So minus 1 plus 1 is equal to 0, and this has the height 0, this has the height 1. So how about the balance factor of this node? Balance factor is equal to height of left subtree. So इसका जो left subtree है that is empty and having the height minus 1 minus height of right subtree. So height of right subtree is 0. This one, the height of 2 is 0. So we can get it as minus 1 minus 0 is minus 1. So it means all the nodes, they are in the domain or in the range of AVL tree, means this has the balance factor 0, this has the balance factor minus 1. So no need for the rotation. Okay, so next, add 3. So we see the 3 will be added to the right side of 2 like this one. So once we inserted 3, we can we know that this node will update the heights of the tree. So heights will be starting from the bottom up. So this has the height 0, this has height 1, this has height 2. Okay, and the balance factor of this one, you can see the leaf node will be having balance factor 0 because we have calculated for 2, and for this also height of left subtree which is minus 1, height of right subtree which is again minus 1. So minus 1 into minus 1 plus 1 is equal to 0. So the balance factor is 0. यहाँ पे क्या होगा? The balance factor will be height of left subtree minus 1 which is, and minus height of right subtree, this one 0. So minus 1 minus 0 is equal to minus 1. So it means this is also balanced, but we need to check up to the root level. So we will see the for this node, height of left subtree, in this case height of left subtree is minus 1 minus height of right subtree. The height of right subtree for 1 is 1, so this is equal to minus 2. So it means this is the node where some balance factor change has been identified. So we can call it as the alpha node, and we will now see which rotation case we need to apply. So this is the alpha node, and this is the insertion to the right side of the right child to the right side, यानी अल्फ़ा के राइट चाइल्ड के राइट की तरफ इंजर्शन है. तो डू यू रिमेंबर विच केस ऑफ रोटेशन इज़ दिस वन? Yes, it is a case of single rotation, so it will be like this one. So single left rotation like this one. So if we make the balance of this tree, so it will be like this. We need to clip on this 2 and rotate to the left side. So 2 is now root node, 1 is here, and 3 should be the right side. So now please remember, once we perform the rotation like from this tree to this tree, the property of binary search tree should not also be disturbed. For example, if we look at this tree, all the nodes will be having balance factor 0, 1 or minus 1, and the property of balanced binary search tree is also maintained. For example, this 2 is greater than 1, so 1 is on the left side of the 2, 2 is less than 3, and 3 is on the right side of the 2. So that completes the rotation of this first case. Okay, so this is with the this simulation. So minus 2 is the balance factor. We need to rotate at this point. So once we rotate, we will be getting the tree like this, and that is already in the balanced form. If we can check, this will be having a 0 balance factor, this will be having 0 balance factor, and this will be having 0 balance factor as well. So it means no more rotations. Okay, next insertion is value 4. So if we insert the value 4 in this given tree, what will be the position? What will be the position of the 4? Yes, 2 के right पे 3 and 3 के right पे 4. So 4 will be inserted at this point. So once we inserted the 4, we will check whether the balance factors are in the range or not. Apparently it is not, so but we will check. So balance these are the heights, height of this one, height of this one. This is the height 1 plus the height of the bottom. Here we can see the heights are coming from the leaves from the left and right subtree. So what will be the height of 2, either 0 or 1? So we will take the longest one, the deepest path. So in this case we consider the height of 2 should be 1, this one. So the height of 2 is 1. So now the balance factor of leaf nodes, we know already that the leaf node will be having balance factor of 0. So this will be also 0 balance factor. I will try to write the balance factors on the upper side and the heights on the lower side. So if we look at 3, the balance factor of this one is height of left subtree, which is -1, because this is the empty one. इसका जो left subtree है, this is empty one. So that because of that the height of left subtree is -1 minus height of right subtree. So height of right subtree is this one, 0. So balance factor is -1. Okay, so it means there is no rotation needed, but this is the insertion and we need to check up to the root level. So balance factor of this node is height of left subtree, which is 0, minus height of right subtree, this one, which is 1. So 0 minus 1 is 1. So it means this is also in the range. So balance factor of this is also -1. So no need to perform any rotation while inserting the value 4. Okay. Insert 5. So once we insert the value 5, we will see 5 will be inserted at the right side of the 4 at this point. So 5 inserted here. Once inserted, we will quickly update the heights. So height is 0, 1, 2, 3. Here we keep it for the time being. So 0. So now we will check which is the longest path. We will give the height to and root node for that. So 2 is the longest. We give the height of 2 as 2. So now we calculate the balance factors. Of course this one is the leaf node, so it will be having 0 balance factor. Please also remember that the insertion, for example in this case the insertion is on the right side of the root. So if there is any change in balance factors, it will be reflected on this path. So we don't need to check the second path, or left subtree in this case, because it will not be imbalanced. So we only need to check this path. So this is already balanced. This is we can calculate height of left subtree is -1 minus height of right subtree. So इसका जो right subtree है, that is having height 0. So it is equal to -1. So how about this one? Here we have the height of left subtree is -1 and height of right subtree is 3 के right subtree की height is 1. So what is the value? -2. So at this point this is -2. As soon as we identified, we will perform the rotation at this point. But before performing the rotation, just to let you know that at this point this is also a disturbed balance factor. So if we for the sake of just understanding, we calculate the balance factor at this node, it will be 0 minus 2. So 0 minus 2 is minus 2, so balance factor of this is also minus 2. But remember, we did not perform the rotation for this one. Once we will perform the rotation for this node, we will see that this node will no more be having the balance factor of minus 2. Okay, so just look at this. So this is a simple case of insertion. This is the alpha. अल्फ़ा के राइट सब ट्री के राइट की तरफ इंजर्शन है, तो इट मीन्स दिस इज़ अ केस ऑफ सिंगल रोटेशन like this one, single left rotation. So this will be let's separate this tree here. So 3 and this is 4, this is 5, this one, okay, this one. So if we rotate it around this point, so it will be like this. 4 का जो लेफ्ट है that will be 3 and जो 4 का right है it should be 5. So once rotated, we will attach this particular side to the right side of this 2 like this one. So once done, we will see that the balance factor of 2 is also now in the range. So we can see that at this point there are no nodes which is having balance factor of 2 or minus 2. So let's look at this with this annotated one. So minus 2 है इसका balance factor, इसको हमने rotate किया इस point के ऊपर, single left rotate. So after single left rotating, we get the this kind of tree, and now we can see all the nodes, they are in the balanced form. For example, the balance factor of this is 0, the balance factor of this is also 0, इसका भी 0 होगा, applying the same formula of height of left subtree minus height of right subtree. इसका जो होगा that will be height of left subtree is 0 and the height of right subtree, this one, इसकी जो height है that is 1, because this has the 0 height, this has the 0 height. So इसका जो balance factor है that is 0 minus 1. So 0 minus 1 is minus 1. So it means this is already in the balanced form. So you just see that after this rotation, we get the all the tree balanced. So what next? Insert 6. So 6 will be inserted where it is compared with the root node, which is 2. So it is greater than 2, greater than 4, it's greater than 5. So 6 will be added to the right side of this 5. So this is the insertion. So we just only need to check this path for the imbalance. This will not be affected. So just first update the heights, 0, 1, 2, these are the heights. इसकी 0 और इसकी क्या होगी, it will be 2. Okay, how about the balance factor of this? 0, this one, height of left subtree minus 1 minus 0, so it should be minus 1. So up to this point all is okay. How about this one? Height of left subtree, which is 0, minus height of right subtree, which is 1. So 0 minus 1 is equal to minus 1. So it means the balance factor at this point is also in the range. No need to the rotation, but we will move towards the root to check the balance factor of this one. So this is the height of this one. So balance factor of this is height of left subtree, which is 0, minus height of right subtree, which is 2. So 0 minus 2 is equal to minus 2. So it means this at this point we have got one node which is in the range of minus 2. So it means this should be treated as the alpha node. So alpha node is there, it means we need to perform some rotation case, and this is the value which is just inserted. We call it, for example, x, and this one. So we try to identify which case of rotation is this one. So this is the insertion on the right subtree and right side of the right subtree. This 6 is inserted on the right side of the right subtree of alpha. So it is a case like this one. ठीक है जी, जो simplest case था, it is like this one. So this is a case of single left rotation. So this will be performed like this one. So this is the balance, having balance factor -2. So it means we need to rotate around this value 4. So this one. So it means we will be rotating this one around this node 4. So let's look how it will work. Once we move from this point to the left side, left rotation, 4 will become the root node like this one, and जो 4 का left होगा, left बनेगा, that will be what, this 2, or whatsoever is on the left side of the 2 will be remain as it is. So 2 का जो left है, it is having a single node which is value 1, so it will be there as it is. How about the left side of this 4? Because this should all be less than the value 4. It means it should it is less than 4, but it is greater than this node 2. So it means this value will be coming to the right side of this 2. Whatsoever the tree is here, it will be added to the this one 3 here, and rest of the tree will be like this 4, 5, and then 6. Okay. So after performing this single rotation, we will see the properties, two properties. One is the BST property, binary search tree property. It should be maintained. For example, we can quickly look. Okay, 3 is less than 4 and greater than 2, so it should be here, fine. 5 is greater than 4, 6 is greater than 5, so fine. So all the nodes, they are having balance factor of range like 0, 1 or -1. So it means after performing this rotation, this will be the resultant tree. So let's look at this -2, and then rotation is at this point moving leftwards by picking the value 4. So it will be like this 4, 2, 2 के right पे whatsoever was the left of 4, it will become the right of 2, and 2 का जो left था, that will remain as it is, or 4, 5 and 6. Now this is the balanced. We can quickly check the balance factor of all the nodes. They will be 0, 1 or -1. Okay, next insert 7. So quickly insert 7, where it will be to the right of the 6 यहाँ पे. So after inserting 7, we will now see this part will not be affected because the insertion is on the right side. So we need to check this one. So once we are expert, we can quickly identify that this will be the point where the rotation need to be performed, because this is making a pattern of single left rotation. So you can calculate by yourself the balance factors, but it should be having 0, it should be having -1, it should be having the -1 into +1 -2. इसका जो balance factor होगा, that will be -2. It means this will be the alpha node. So we can identify this is a case of single left rotation. So we will rotate this, and after rotation we will get a tree like this 6 के जो left पे होगा, that will be 5, and जो 6 के right पे होगा, it will be 7. Okay, and rest of the tree, it will be remaining same. So 4, this one, this one 4 का 2, 1 and 3. So whatsoever is, so इसका जो right child होगा, it will be like this. So once done, it will be a complete AVL tree and keeping the properties of the binary search tree. So let's look at this. Balance factor is -2 at this point, so we need to perform, as we discussed earlier, the single left rotation. So this one, okay, so this will be the rotation which is already performed. Okay, what next? 16. Insert 16 is also inserted at this point. So after inserting the value 16, we can check the first we will see this part will be affected if we need to perform any rotation that will be performed on this path. So let's look at this, whether it is needs a rotation or not. So heights 0, 1, 2, 3. So balance factor of this will be 0 because this is a leaf node. This will be having balance factor of -1. This will be having balance factor of height of left subtree, which is 0, minus height of right subtree, which is 1. So 0 minus 1 is -1. So how about this? इसकी जो height है 0, 1, height of left subtree, which is 1, minus height of right subtree, which is 2. So it means it is -2. Sorry, -1. 1 minus 2 is equal to -1. So it means there is no need to perform any rotation after the value 16 has been inserted. Okay. So how about this 15? If we insert the value 15, then again we need to check this path whether it is imbalanced or not. So let's quickly check 0, 1, 2. These are the heights. How about the balance factor of this? Because this is a leaf node, so balance factor is 0. How about this one? The height of left subtree, which is 0 minus -1. So the balance factor will be 0 minus -1. So 0 plus 1, which is equal to 1. So balance factor of this 1, it means no need to rotate. How about this? Height of left subtree, which is -1, minus height of right subtree, which is 1. So it is -2. So it means this should be the alpha node. Okay, so this is the point where we need to perform the rotation. But which kind of rotation we need to perform is, we can see the insertion is on the left child of the right child of alpha, यानी अल्फ़ा के राइट सब ट्री के लेफ्ट की तरफ इंजर्शन है. तो यू कैन रिमेंबर दिस इज़ द केस ऑफ double rotation like this one. Okay, so if we look at this is a case of double rotation in which we will perform first the single right rotation, which will give us a tree like this one. इस पे यहाँ पे होगा और this one is here. Okay, and then we need to perform a single left rotation. So around this node, this and this. So this will be attached to the this one. But if we for example, if we incorrectly identified the case of rotation and we treat it as a case of single rotation, for example, in this slide we can see this is treated as the -2 and we perform some wrong rotation. So we will be getting something like this one, and this will be already in imbalanced form and we will never be able to balance this given tree. So please remember, once a new value is inserted, we need to very carefully insert or perform the rotation case. So these are the again the repetition of the cases for rotation, because now we are going to perform some double rotation. So you can go through this and keep in mind, because we have discussed these cases several times. It is just here for your recall. So an insertion to the left subtree of right child of the alpha. So an insertion to the right subtree of right child of alpha. So these are four cases, single and double rotation cases, which we have already discussed, and this one is the description of those cases. So just go through these one, and this is the again kind of repetition which we done in the previous lectures. So you can check it, and you can go through these generic rotational cases, that how it will work. So I will for the time being quickly pass through it. If you feel any confusion, you can talk to me. I will directly tell you how to construct a particular tree like we were doing before. So this is how we need to perform the rotations. This already we have discussed in our recent examples. So this is just for more explanation of the cases for you. Okay, so case fix 3, fix case number 4. Okay, this insert 15. So insert 15, we identified that this is the alpha node, and the case is of double rotation. So first we need to perform the single rotation here. So once we perform the single rotation, it will look like this. 7 की जो राइट पे होगा, अब ये 15 आ जाएगा. So 15, and now 15 के राइट पे क्या होगा, this 16. Okay, so after performing first rotation, it will like this, and then we need to perform a single left rotation. So 15, this we are familiar with performing the single rotations. 15 का जो left होगा, it will be 7, and इसका जो right होगा, it will be 16, like this one. So once completed, we will attach this one to this one, and once this has been attached, we will see that the tree is in the balanced form, and there is no need for the further rotations, because all the nodes will have the balance factor of 0 or -1 or 1. So this is how it works. We will see rotate right first around this point. So once we perform the right rotation, it will be like this: 7, 15, 16, and then now we need to perform again a single left rotation at this point. So as done before, at this point we perform the single left rotation. So 15, 7, 16, that's all. So after this rotation, if we see, there will be no node which is out of the balance factor. Okay, so this is the balanced tree. Now next is value to insert is 14. So identify 14 will be left of this one, और इसके जो होगा वो right पे होगा. So check at this point where the imbalancing is occurring, and perform the rotation. So we will continue with some more examples of the AVL construction tree. I'll also give you some data sets, some values, and you need to perform the need to construct the AVL trees by using those data sets, and send it to me via the WhatsApp, or I will tell you the platform where to upload. Okay, so for this lecture we are done with, and we discussed the 4 cases of the rotation: single left rotation, single right rotation, double rotation, and we constructed some trees. So please practice these trees, construction of these trees, and let me know if you have any questions. And thank you very much, and Allah Hafiz.